Good afternoon. We will carry on with the things that we left yesterday, that is the proof of the Marshall-Lerner condition, which says that a devaluation or depreciation will improve the current account balance if the sum of foreign and home import demand elasticities are greater than 1. Now, this condition is proved under stringent assumptions, that is, home and foreign prices and home and foreign incomes are constant. And when I say stringent assumptions, one already knows that if there is a switch in expenditure, it tends to have an impact on the aggregate demand, and if the aggregate demand changes, it has an impact on prices and incomes. So, it may negate the impact of the change in the nominal exchange rate on trade balance. So, the expenditure changing policies or absorption approach is considered to be the most likely partner of the expenditure switching policies, because you need the expenditure changing policies to complement the expenditure switching policies for exchange rate changes to have full blown effect on trade balance. So, first I will quickly go and derive the Marshall-Lerner condition, and then we will see that how trade balance is a function of the real exchange rates. Once we do that, then we will see how expenditure changing policies can be complemented with the expenditure switching policies for exchange rate changes to have a full blown effect on trade balance. So, the first thing that you do is to define the trade balance. This is in terms of the local currency. So, you have P1 C1 star minus pi P2 star C2. This is the exports, value of exports in domestic currency. This is the value of imports in local currency or domestic currency. So, then the change in trade balance is P1 C1 star, P1 proportionate change in the price of exports plus the proportionate change in the export demand minus pi P2 star C2 pi dot plus P2 dot star plus C2 dot, where the dot denotes proportionate changes. Now, the export demand, this is the export demand. This is a function of P1 star, P2 star and incomes prevailing in the foreign country. So, then using the total differential rule, dC1 star is del C1 star del P1 star dP1 star plus similarly home import demand is a function of P1, P2 and income, its own price, that's P2, P1 the price of the other good, which is the export good, and the domestic incomes. And so the change is this is the using the total differential rule. So in the first, you divide by C1 star and multiply and divide by P1 star, divide by C1 star, P2 star, P2 star, C1 star, Y star into Y star. So what you would get from here is C1 dot star, the proportionate change in the export demand. This is the proportionate change is the foreign export demand elasticity minus E1 star P1 dot star plus E2 star P2 dot star plus EY star Y dot star, where E1 star is the home is the foreign export demand elasticity. E2 star is the foreign cross price elasticity. You don't know the sign because it depends on whether the good is substitute or the complements. And then you have the income elasticity, which is greater than 0 because you are considering your export good to be a normal good. So you get this from the second C2 dot, you get E1 P1 dot minus E2 P2 dot plus EY Y dot. E1 is the cross price elasticity, E2 is the home import demand elasticity, and EY is the home income demand elasticity. So how did I get this? Again, I divide by C2, divide by C2, divide by C2, multiply and divide by P1, and then define E2 to be this is the Then you also define P1 star, which is P1 by pi. So P1 dot star is P1 dot minus pi dot, and pi P2 star is P2, so pi dot plus P2 dot star is equal to P2 dot. So you have this, and you have the proportionate changes in the export demand, the proportionate change in import demand. Now the only thing that you need to do is now you have to put it in this equation, which is the change in the trade balance, and we are going to put it there and then see what we get. So look at this term here in the terms inside the first parenthesis. Instead of P1 dot star, I have replaced it with P1 dot minus pi dot. And in the second parenthesis, I have replaced this term P2 dot with pi dot plus P2 dot star. And then noting that the initial trade is balanced, that is, exports are equal to the imports, and the prices are fixed, there are no changes in the prices and incomes. We will see what we get from here. Yeah, EY y dot, yeah. Okay, so because the home and the foreign prices are fixed, so there are no changes. Huh? Yeah. Okay, so dn See, noting that the trade is balanced and P1 dot is equal to P2 dot is equal to 0, there are no changes in the incomes. What you are left with will be these terms, pi dot E1 star minus pi dot plus E2 pi dot. Now, this was the foreign export demand elasticity. This was the home import demand elasticity. This was the foreign export demand elasticity. This was the home import demand elasticity. So then you get the change in trade balance as a function of the proportionate change in the exchange rate and this term, and if the Marshall-Lerner condition says that if the sum of the foreign export demand elasticity and home demand elasticity is greater than 1, then you get a positive term here, and if there is a depreciation, that means pi dot is greater than 0, then only you will see an improvement in the current account balance. So that's what Marshall-Lerner condition says, that if the sum of the home and the foreign export demand elasticity is greater than 1, then only depreciation, that is when pi dot is greater than 0, it would lead to an improvement in the current account balance, provided you have E1 star plus E2 minus 1 to be greater than 0, or E1 star plus E2 to be greater than 1. Foreign export demand elasticity. Export demand, you are exporting their demand for your exports. Foreign export demand, that means whatever you are providing, your exports, you are supplying something, it's the demand for that particular exports. Export.
You have mentioned that E1 is the foreign import demand.
Did I mention foreign import? No, home import demand elasticity, if there is, then you make a correction. Export demand elasticity. Home import demand elasticity, foreign export demand elasticity. This curve that you have is the export demand curve. The export demand curve. So when I said, probably what I would have meant that if you are in foreign, then it's their home, their demand elasticity, their whatever is your export is their imports. So maybe it's import demand elasticity from their point of view. Whatever is your export is their demand, and so whatever is your export is their imports. So you can always say that foreign, if you are existing in, you are living in a foreign country, so their import demand elasticity, and then we become foreign. But whatever it is demand elasticity, import and foreign and home export and import demand elasticity.
In the definition it is mentioned that if sum of foreign and home import demand elasticity.
Yeah, so see, what I am saying is that if you are considering this to be a foreign, if you are in foreign country, then it becomes whatever is your export is your imports. Okay, so export demand for us and import demand for them. So in many of the books, this definition also works, provided you understand what they are saying. So whatever is your imports is their exports, right? And whatever is your exports is their imports. So this foreign export demand elasticity is import demand elasticity for the foreigners, because whatever is your exports is their imports. Okay. Home import demand elasticity is whatever is your import is their exports. So if they write, they would say export demand elasticity existing in India. Okay. So then the important thing is that these are demand elasticities, export demand elasticity from our point of view, from their point of view it's import demand elasticity. This is from our point of view import demand elasticity, for them it is export demand elasticity, because whatever is our imports is their exports. So this tells you that the change in trade balance is a function of this only, pi dot plus E1 into E1 star plus E2 minus 1. If E1 star plus E2 minus 1 is less than 1, then appreciation of the exchange rate will improve the current account balance. So from your point of view, it will be interesting to look at some econometric studies which have worked out these elasticities. It's not that simple, but you should look at the Professor Stern's work. Professor Stern's work, who has worked out these elasticities using different econometric equations. Further, we will show that the change in the trade balance is a function of the real exchange rate and the changes in incomes and prices. So what we will prove now is that dn will be P1 C1 star we will get pi dot plus P2 dot star minus P1 dot star E1 star plus E2 minus 1 So what we will derive now is that the change in the trade balance is a function of this MLR condition E1 star plus E2 minus 1, and here you would have pi dot plus P2 dot star minus P1 dot. So this is the changes in the real exchange rate, where the real exchange rate is pi P2 dot P2 star P1. The real exchange rate is the reciprocal of the terms of trade, pi P2 star by P1. So R dot, if the proportionate change in the real exchange rate would be pi dot plus P2 dot star minus P1 dot. And then it's a function of the real incomes existing in home and foreign country. So see what happens in actual practice when you depreciate your currency. It tends to have an impact on either incomes or prices, because whenever there is a switch in expenditure, say from foreign to home goods, the aggregate demand in the economy goes up. When aggregate demand in the economy goes up, it tends to have an impact on the prices and incomes. So it's possible that pi dot is greater than 0, but then it's also possible that P1 dot also goes up. Your domestic prices also go up. As a result, there is no change in this figure. The real exchange rate remains the same. Marshall-Lerner condition is satisfied, but there is no change in the real exchange rate. As a result, you see no changes in the current account balance. So, if you look at the history of the devaluations which are undertaken by countries, especially the ones in Latin America, they devalued their currency heavily, but they found that the inflation was also creeping in. As a result, there was no change in the real exchange rate and there was no change in the trade balance. When India liberalized, India did a heavy depreciation in the mid 60s of the level of 36%. If you see the impact on the prices, it was moderate. Okay. So, there was some impact on the change in the trade balance. But what Latin Americans did in the 80s was that they did not supplement or complement the expenditure switching policies with the expenditure changing policies. Because as soon as you depreciate your currency, the domestic price of the imported good goes up. Okay. And then it brings in inflation in the economy. And you already know that when prices changes, the change which should come about in the export demand or the import demand is little sticky. It's not that if you change the prices today, immediately you will see a change in demand. It takes time. So, what happens is that initially when you do devaluation, there is a possibility of something like a J-curve phenomena. A J-curve phenomena. Now, look at this J-curve. The current account balance, instead of improving, initially first goes down and then after some time it improves. This happens because the demand does not respond immediately to the changes in prices. So, you see a J type of phenomena, and then this current account balance is not only a function of the real exchange rate, the real incomes in foreign and home country, but set of other factors also. Current account balance is a function of many other variables. So, even if you are changing the nominal exchange rate, incomes may be changing. That also has an impact on the current account balance. So, many countries have observed this J-curve phenomena. Many countries have seen inflation creeping in because of devaluation. Many countries have seen changes in incomes, and so this change in trade balance is always a lagged impact of the changes in the nominal exchange rate. So, it will be interesting for you to find out in case of India that whether these changes in exchange rate has immediately having an impact on the trade balance, or is there a lagged impact? What can be the other factors which have an impact on the trade balance? So, you can go into that type of question. But given this equation, at least you have an equation to estimate. You have an econometric equation to estimate, wherein you can have all these, you have to convert it into an econometric equation, wherein it's possible that you have data on these, put this as your parameter if you are not able to calculate the elasticities. You have data on the real incomes, consider this as to be your parameter, and then maybe use nonlinear least squares to estimate the equation, wherein you get some idea of this, this and this. So, by estimating this, you can get some estimates of the elasticities, Ey star, Ey, E1 star plus E2 minus 1. But there are studies which straight away estimates these elasticities in an econometric specification. Once you have the equation with you, once you have the regression equation, you can put these values and forecast the value of the trade balance. That you can do. Or if you want to start with a very simple exercise, you have these exchange rates. In the economic survey, you will find a figure for nominal effective exchange rate. You will have a figure for real effective exchange rate, which are like a weighted average of the bilateral exchange rates. Plot this against the current account balance for India. Just plot these two figures, and with in the Excel, make a red line and a blue line and see whether they go together or they are converging or diverging. So, if one does an exercise for the United States, see what you get. You get, this is a handout which I distributed yesterday. Look at the figure 18.4. Look at the figure 18.4. This is plotting real effective exchange rate. It is not a bilateral exchange rate, it is a weighted average of the bilateral exchange rates of US. So, real effective exchange rate on the y-axis, and then trade balance on the other side, that is y-axis, and in the x-axis you have years from 1975 to 2005. So, at least till 2000 you find that when the real effective exchange rate increases, the trade balance goes up. When the real effective exchange rate decreases, the trade balance goes down. There is some sort of a lagged effect, but then it gives an indication that probably this is true, that when you depreciate your currency, it tends to improve the current account balance. Except for years from 2000 to 2006, where your trade balance and your real effective exchange rate, they are diverging. The depreciation is not able to improve the trade balance. So, wouldn't it be interesting to do it for India and work out whether this has been happening? And if you find evidence that if it is not happening, then you may think that the trade balance is not only a function of the exchange rates, but it is also a function of the prices and the real incomes. Okay. So, this you can do. Economic survey already gives the real effective exchange rate, REER and NEER data from right from 50s till date, and you have the current account balance. You just have to see whether there is a long term relationship between the two variables. If you have to find the long term relationship, there is something like a co-integration which you can do, or you can just find out the correlations over time and see and plot them and see whether the two are correlated with each other. In this process, you will come to know about this REER, real effective exchange rate, which is not a bilateral exchange rate. It is like a weighted average of the bilateral exchange rate which exists between India and its trading partners. and they report a 6 country and a 36 country weighted average index. So look at that and then see whether you can see any relationship between effective exchange rates and trade balance. If you wish to test the J-curve phenomenon, that means if exchange rates are improving, your current account balance is going down and then it is going up. So it's like a inverted U. So you know which type, if you have to estimate this, you know which type of econometric equation to fit. It will not be y is equal to a plus bx, it will be y is equal to a plus bx plus cx square. Okay. C being positive, B being negative because it is U shaped. So you have two variables which are exchange rate and you have the current account balance. Okay. So exchange rate is changing, the current account balance is going down and then it is going up, right. So then you can have a parabolic type of relationship between exchange rates and the current account balance, just to test the J-curve phenomenon. And then you can have a bigger specification, right. Current account balance as a function of not only exchange rates and exchange rate squares, but incomes, prices, and then you estimate the model. So that you can do. On the current account balance. The first, and because there is a lagged effect, the current account first deteriorates and then after some time it goes up. So maybe you have a lagged variable on the right hand side, something like a lagged variable, right. So think of many specifications. So when you go into it, you will read literature on this J-curve phenomenon. So, and then as I said, working out the elasticities is something that you could do, how to get the elasticities, and there is a whole lot of literature followed the Professor Stern's work, then followed by Micheli's work way back in the 50s probably. Okay, so then the last thing that we need to prove is this. I don't know whether we have much time. Can you try it back home? Right. So what you need to do is something, what you need to do is define this demand function, and you already know the demand function is homogeneous of degree 0. If it is homogeneous of degree 0, you already know a homogeneous function this is a homogeneous function of degree r. Okay. So if r is 1, it is homogeneous of degree 1. If r is greater than 1, it is homogeneous of degree 2. If r is less than 1, homogeneous of degree less than 1. If r is 0, then it is homogeneous of degree 0. And you already know that the demand functions are homogeneous of degree 0. So what you would get would be C1 star lambda P1 lambda P2 lambda y star. Okay, because lambda raised to power 0 would be 1, so you get C1 star to be this. Now if this is so, then use the Euler's equation. Remember the Euler's equation, which was Rz, if z was a homogeneous function, Rz del z, del x, del k, k plus del z, del L, L. This was the Euler's equation. It's not the total differential rule, it's R is the degree of homogeneity. So you will get 0 equal to del C1 star del P1 star into P1 star plus del C1 star del P2 star P2 star plus del C1 star del Y star Y star. So then you convert it into elasticities. So you do it for foreign and home, and then put it back in this big equation, replacing the value of E2 star and replacing the value of E1, and then collecting the common terms, you will get this. So then trade balance is a function of the real exchange rate and the real incomes. So even if there is a change in the nominal exchange rate, prices and incomes may change to negate the impact of the nominal exchange rate. As a result, there will be no change in the current account balance. But it's an empirical thing. You need to look at each country's data and see whether this holds or not. So it's up to you to take it up. Okay, so I will end up here. Next time we will see how absorption approach and elasticity approach are complementary to each other. Thank you.